curve sketching scenario, but now we have a rational function. Okay, and what do we know about rational functions? Well, we know that this here, or function in general, we know that this 4 here means it's been shifted up 4. This is also going to deal with something. So let's just see what we have. Okay, let's think about our intercepts. We have x-intercepts. Let's do blue today. My x-intercept means that I'm going to set y equal to 0. So I get 4 minus 1 over x squared minus 9 is equal to 0. I'm going to bring this over, so I get 4 is equal to 1 over x squared minus 9. Cross multiply, I get 4 x squared minus 9 equals 1. And I can say that 4x squared minus 36 is 1. And 4x squared is equal to 37. X squared is equal to 37 over 4. And so x is equal to plus or minus the square root of 37 over, well, 2. Well, square root of 37 is a little bit more than 6. 6 divided by 2 is 3. So it's approximately plus or minus 3.1. I'm going to guess approximately that. If I don't have a calculator, that's about as good as I'm going to get. Okay, so I know I have x-intercepts there. So let's put on 3.1 negative and 3.1 positive. Okay, so here are my x-intercepts. Y-intercept means that I'm going to let x be 0. So if I'm going to do the y-intercept, I let x be 0. And so I get 4 minus 1 over 0 minus 9 is 4 plus 1/9. So my y-intercept is going to be x equals 0, and y is 4 and 1/9. Just a little bit bigger than 4. So I know 1, 2, 3, 4. My y-intercept is just going to be a little bit bigger than 4. Now what else do I know about this scenario? Well, if I look at my bottom of my fraction here, I have limitations on here. I know this is not allowed to be 0. So let's find out where it's going to be 0. If I let this equal 0, and these are going to be my vertical asymptotes, where the denominator equals 0. So x squared minus 9 is 0, so x squared is 9, and so x equals plus or minus 3. These are the equations of my vertical asymptotes. So let's go over here. Let's find our vertical asymptotes. We'll go here to here. So we're going to have a vertical asymptote here, just shy of my x-intercept. And another vertical asymptote here. Okay, let's maybe move those over just a, I think this one's okay. I'll move this one over just a touch. Okay, so 3 and negative 3. Okay, now what else do we know? Vertical asymptote, horizontal asymptotes. Well, I know if this is one big fraction, then I could figure out what was going on with my top compared to my bottom. So let's bring this together. Let's deal with the horizontal asymptotes now. So the horizontal asymptote gives me, I'm going to get a common denominator, so I'm going to put all over x squared minus 9, which is f of x, and it's going to be 4 times this minus 1, which gives me 4x squared minus 36 minus is 37 all over x squared minus 9. So for our horizontal asymptotes, we're looking at the degree of the bottom, the denominator, and the degree of the numerator. They're equal, so the horizontal asymptote is going to be the leading coefficient. So the horizontal asymptote is simply y equals 4. You have to make sure you write it as an equation. So let's go over here now. Let's look at a horizontal asymptote. And we'll do here, and we want y equal to 4, which is, there we go. So now, looks like we got to find out where region it's going to be. And I know it's going through here and here. Let's go and look at increasing and decreasing as and concavity. Okay, so in order to find increasing, decreasing, max, min, I need to find my first derivative. And let's get an extra page going on the go here. We'll copy this so I can keep it. Let's copy it. Let's make a new page, and then I'll paste it down. Okay, so now here is my function. Let's start looking at the derivative. So f prime of x is going to be, I take the derivative of 4, well that's 0. I have a minus sign here, and so I'm going to, and I have quotient rule, but let's also think about this. I could write this whole equation, actually f of x I could write as 4 minus x squared minus 9 to the minus 1. Now the reason why I do that is because now I can avoid doing the quotient rule. Now I can use chain rule, which is much easier. So if I do f prime of x, the 4 vanishes. So let's get rid of that 4. Get rid of that. And now let's go and take the derivative. Derivative of 4 is 0. I bring the negative 1 down. Negative times negative is a positive. And I get x squared minus 9, subtract 1 squared, times the inside, derivative is 2x. So I get a 2x over x squared minus 9 squared. If there's going to be a maximum or minimum, this derivative has to be 0, which means 2x equals 0, and so x equals 0. And so if I make my sign chart, f prime, f, I'm going to have to put on my asymptotes and my critical number of x being 0. If I go over here and I look at negative 5, let's say, that's going to be negative on the top. And the bottom is always going to be positive since it's squared. So it's negative overall, so that means it's decreasing. If I look in between negative 3 and 0, it means a negative number again. That's negative. That's positive, so again, negative. Look at bigger than 0, so positive 1, let's say. That's positive, so altogether, positive. Looking over here at 3, that's so like 5, let's say, so that'll be positive. The bottom will be positive, so positive. So it's decreasing, decreasing, increasing, increasing. So I know this value here is a minimum. Okay, so now we know we have a minimum there. Let's also now go and look at concavity, and then we'll piece it all together. F double prime of x is for concavity. Now if I look at this function here, I have this way or this way, and I can use, if I do the derivative this way, I'm going to have to use product rule. If I do it this way, I have to use quotient rule. I'm going to go for product rule because I think it'll be tidier when it's all said and done. So the quotient rule says I'm going to take the derivative of the first, so negative 2 x squared minus 9 to the minus 3 times the inside, which is 2x, plus, oh, hold on, I gotta remember to write the derivative still, 2x. So that's the derivative of the first part, which is all here, times the function, plus x squared minus 9 to the minus 2 times the derivative of the last one, which is 2. Alright, so now if I tidy this up a little bit, let's see what we can get. If I rewrite this, I get negative 8x squared, negative 8x squared over x squared minus 9 cubed plus 2 over x squared minus 9 squared. Well, if I'm going to bring these together, I'm going to multiply. I have to get a common denominator. So let's multiply this by x squared minus 9 over x squared minus 9. And so I'll get minus 8x squared plus, well, 2x squared minus 18. And that's all over x squared minus 9 cubed. Keep simplifying, and I get negative 6x squared minus 18 over x squared minus 9 cubed. Okay, so points of inflection means this thing here is going to equal 0. The bottom cancels, and I get negative 6x squared minus 18 is 0. And so I get negative 6x squared is equal to 18. If I come along now and divide by negative 6, I get x squared is equal to negative 3. Well, x then is equal to plus or minus the square root of negative 3, which we don't have. So the conclusion then, there are no points of inflection. Well, what does that mean in terms of concavity? Well, that means that it never changes concavity from concave up to concave down. There's no except where there might be asymptotes. So we have to look at our asymptotes as turning points. They're not defined, so they're not actual part of the function, but we have to look and see what's going on either side. So here are my asymptotes. It's not defined at negative 3, so I'm going to put an x there. And if I look at my derivative, my second derivative, which is this part here, okay, I'm going to pick a number like negative 10. If I plug negative 10 in here, I get a big positive number times that negative, which is all negative on the top. So it's negative on the top. If I plug negative 10 in here, that's a big positive, minus a small negative will be positive cubed, so it's positive. So this is going to be negative overall, which means that the function is concave down. Oh, sad face, he's so negative. Okay, let's look in the between the asymptotes. Let's plug 0 in there. If I plug 0 in here, that cancels, get negative on the top. If I plug 0 in here, that becomes 0 and I get negative 9 cubed is also negative, so two negatives multiply to get a positive. So he is concave up. He's a happier guy. Hey, concave up. He's so positive. And then to the right of 3, let's pick, let's say 10. Again, this is squared, so it's going to end up being a negative on the top, a positive on the bottom, and so altogether it is one negative fellow. Concave down. Negative, negative, boo-hoo. Alright, so I know I have concave down, decreasing the whole time, increasing the whole time, and concave up. Well, if I put all those pieces together, I know it's got to be concave down here through this point, and it's got to be decreasing. So it's coming down through here, decreasing. I know it's concave up between 3 and here, and it is in decreasing still, and then it goes to increasing because there's a minimum point. And again here, it is increasing, 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 concave down the whole time. So that's what my graph is. We probably could have figured out what the graph was without all that analysis, but there's all the gory details. Let's check and see how that is. If I actually put it into my calculator, my grapher, I get this, which is indeed what we have. All right, good.